So today we're going to start a new unit. This is Unit 4, all about curve sketching. And the idea is throughout this unit we're going to develop a whole bunch of tools. So by the end of the unit I can give you some random formula. We can analyze it using some tools from calculus and get a pretty good idea of what the graph of that function looks like. We're going to start in section 3.1 talking about absolute extrema. And before you send me an email to tell me that I got my numbering wrong, no, our units are not necessarily matching up with chapters in the book. Remember, Unit 1 was about limits, Unit 2 was our basic derivative rules in 2.1 through 2.4, and Unit 3 was the implicit stuff and related rates, that was 2.5 and 2.6, so no, I am correct with my numbers. Unit 4, about curve sketching, and again, we're going to start in 3.1 and talk about these things called absolute extrema. I'm going to make the video pause for a moment, get your notes set up, and please copy down that graph that you see. So this graph over here reaches a highest y value and reaches a lowest y value, and we call those absolute extrema, absolute maximums or minimums. This graph has an absolute maximum right over here. That is an absolute maximum. I have an absolute maximum occurring at x equals 1, 2, 3, 4. If, whoops, I messed that one up. Let me try that again. I have an absolute max. We do need that word. I have an absolute max at x equals 4. Now, if I want you to tell me the y value for that point, I would ask for the absolute maximum value. And looking at the graph, the absolute maximum value looks like there's a y value of 3. My absolute maximum occurs at x equals 4, and my absolute maximum value is 3. Next, our absolute minimum. Our absolute lowest y value, I think, is occurring right over here. So that occurs when x equals -1. And our absolute minimum value is, let's see, looks like -4 to me. If I ask you where it occurs, you give me an x value, and if I ask you for what is that maximum value or what is that minimum value, you tell me the y value. Let me give you the formal definition of an absolute maximum and an absolute minimum. By the way, this point over here, this is some sort of a maximum, but it is not the absolute highest y value on the graph. That's over here. It's just the highest y value for part of the graph. We're going to call this a relative maximum, and we're going to look at that more in the next section tomorrow. Here's our formal definition. And this is going to be considering some function f of x on a particular domain D. My definition of having an absolute maximum is I will have an absolute maximum at some particular x value if the y value there is greater than or equal to all the other y values in my domain. I'm going to say f of x has an absolute max at x equals c at some particular x value if the y value there, f of c, is greater than or equal to all the other y values for all x in my domain. Going along with that, I would say that f of c is the absolute maximum value, that y value that's greater than or equal to all the other y values. Take a moment and copy that down. Similarly, I'm going to define an absolute minimum in a similar way. I'm going to say that f of x has an absolute minimum at some particular x value, x equals c, if the y value there, if f of c is less than or equal to all the other y values for all the x's in my domain. In the same breath, I'm going to call f of c the absolute minimum value. Take a moment to copy that one down. If our y value is higher than all the other y values, absolute max. If it's lower than all the y values, absolute min. There is a theorem called the extreme value theorem, which guarantees under certain conditions our function will have an absolute maximum and an absolute minimum. And you know what? I think before I give you that theorem, we're going to look at three graphs. How about you take a moment and copy these down? They're pretty similar, but there are some little differences. I think so. An absolute maximum needs to be an absolute highest y value that we reach, and the absolute minimum needs to be the lowest y value which we reach. And I think this graph over here has an absolute maximum that I reach over there and an absolute minimum that I reach over there. So there is an absolute max and an absolute min. This graph over here, there's an absolute minimum value that I reach, but I don't actually reach the absolute maximum value. If I put some tick marks over here, looks like I'm getting really close to a y value of 4, but I'm never actually hitting it. And my y values can get really close to that, but no matter what y value you come up with, we can always get something a little bit closer and a little bit closer to 4. This graph has an absolute min, but no absolute max, because I don't actually reach that highest y value of 4. Over here, this one does have an absolute max. I do reach that highest y value, but there is no absolute min. I don't actually reach that lowest y value over there. There's an absolute max, but no absolute min. And hopefully these two examples show you two of the requirements that we need to be able to find an absolute max and an absolute min. Our function has to be continuous. This one is not. And we have to be looking at it over a closed interval, meaning we're counting the endpoints. And that's what our extreme value theorem says. It says if f is continuous on a closed interval, a to b, then f of x must reach, must reach an absolute max and an absolute min on the interval a to b. Take a moment and copy that down. As long as we're continuous on a closed interval, which means including the endpoints, I'll have to reach an absolute max and I'll have to reach an absolute min. This one's not on a closed interval. That was why there was no absolute max. This one wasn't continuous, which is why there's no absolute min. The rest of this section will be about actually figuring out where those things occur from our formulas.